Let's get started with functions. Let's first start with a review of the rectangular coordinate system and graphing linear equations. Here's a warm-up exercise. Complete the following assignment. So what I want you to do is write down the coordinates of each point of the face. For example, point A. Point A is here. What point is that? So if you look at the x-axis, we're at 2, and if we look at the y-axis, we're at 5. So I'm going to write 2, 5 for A. I want you to do the same thing for all the rest of the points. So what I want you to do now is pause the video and complete this exercise. Okay, so now go ahead and check your answers. The answers are already written here. And we're going to move on to the next part of the lesson. So for the next part, I want you to fill in the blanks. So there are blank regions called quadrants. So pause the video again and fill in the blanks. So you are correct if you said there are 4 regions called quadrants. When plotting a point, start in the very center called the origin, which is represented by the point 0, 0. First, go left or right on the x-axis, then go up or down on the y-axis. So now what we want to do is we're going to graph. Now, when I'm teaching this lesson in class, I have students to pair up to do this exercise. But since we're not in class, this is online, let's go ahead and graph y equals negative 2x plus 1. This is an example of a linear equation. And I know that because the x is to the first power in this equation and the y is to the first power. So if both variables are to the first power, I know that I'm dealing with a linear equation, which is a line once I graph it. So let's begin. I'm going to create a t-table, as they call it, but I'm going to extend my t-table just a little. We normally put x here, and we decide on numbers that we want to plug in for x so that we can get the corresponding y. And since this is a line, you could choose 3 points and 3 numbers for x. For example, negative 1, 0, and 1. And then what I'm going to do is write out our equation, y equals negative 2x plus 1. We're going to fill that in. Then we're going to write what y equals to. And then we're going to turn around and write the point, x, y. So first, we have y equals, when we substitute x for negative 1, what do we get? Well, we get negative 2 times negative 1, which is positive 2, plus 1, which is 3. So the point first point that we have is negative 1, 3. So what I want you to do is pause the video now and fill in the other points. So hopefully now you have negative 1, 3 as a point, 0, 1 as a point, and 1, negative 1 as a point. So now let's plot the points. So we have the first point, negative 1, 3. So we're going to go 1 unit to the left on the x-axis and go up 3 units, 1, 2, 3. Plot that point, so that's negative 1, 3. Did that one, 0, 1. I'm going to go up on the y-axis. And we have 1, negative 1. So it's a good indication that you're doing the right thing because these points are falling in a straight line. And that's why it's a good thing to plot 3 points instead of 2. 2, you wouldn't know that if you made a mistake or not, but with 3, the third point confirms the other 2 points. So it's best to try to at least do 3 points for a straight line. Even though if you're really comfortable with drawing lines, 2 lines is perfect. 2 points are perfectly fine, but 3 points are better. Moving on, let's talk about what a function is. A function is a relation where every input has exactly one output. And the notation for function is f of x. So we have here f of x, and as you can see from this notation here, y is equal to f of x. So what you normally saw as y, for example, in the previous example, this y could be substituted with f of x because that is a function. In that case, that line there is a function. But we see here the elements of a function. We have the x, which is our input here, and then we have the output, which is what y is. Once you plug in the input, what you get out is your output. And this f notation, it does not mean f times x. It's just notation for a function. The domain of a function is the set of input values or x values, and the range of a function is the set of output values or y values. For example, if we have the relation 2, 3, 4, 6, 6, 8, 10, 6, determine the domain and range. If the domain is just the x's, then we write our little squiggly lines called braces, and we only put the x values as the domain. So what is x? What are the x's of this relation? So you simply just write 2, 4, 6, 10 in this case, and you always open and close it with these braces here. And similarly with the range, you're choosing the y values at this point. So we have the y values, and as you can see, one of our y values repeated. So we have 3, 6, 8. We have another 6, but we already included 6 in our range, so there's no need to repeat that value. 6 is 6 in this case. Now for the previous example, no two ordered pairs have the same first element. So every x value went to one y value. That makes this a function. So if you ever heard the song That's Amore by Dean Martin, you can look it up. Try to sing the chorus and sing if the x that you try goes to only one y, that's a function. And if you can remember that, if the x that you try goes to only one y, that's a function, then you can determine whether a relation is a function or not. So for example, determine the following for the relation 2, 2, 1, 0, 0, 0, 2, negative 2. What is the domain? So what I want you to do right now, I want you to write the domain and range. I want you to pause the video and write down the domain and range. Determine whether you think it's a function or not, and then explain why or why not. Okay, so let's first go over what the domain is. If you wrote 2, 1, 0, you are correct. And notice I put or because it's best to put this in order from least to greatest. So I also wrote 0, 1, 2. It's the same, but it's best to be orderly about math. So if you put either or, I'm fine with it. 0, 1, 2. And then for the range, if you put 2, 0, negative 2, or negative 2, 0, 2, then you are also correct. Now, what did you say about the function or Is it a function? Is it a function or not? So it turns out here that this relation is not a function because 2, the first component 2 is going to 2, but that same first component is also going to -2. So meaning we can't have that same 2 first component going to 2 different y's. So because we're going to 2 different y's, then it's not a function. So again, if the x that you try goes to only one y, that's a function. This x here too, that same x is going to 2 different y's, so it's not a function. Why not? Again, 2 is going to the first component or element, first component. 2 is going to more than one y. 2 and -2. Alright, moving on to some more examples. Here's a real world example. A real world example is the grade that you're going to receive at the end of this course, for example. So if we have, let's say for example, a student makes a 93. Let's say that's the x. That's your input. What would be the output for their grade on their transcript? If their average was 93, they would get an A, right? Now, could a student with a 93 also get a B? No, right? If you can't go to 2 different y's, that's confusion. So that's why we say it's not a function. It's not functioning correctly. If, let's say a student had a 75 in the class, 2 students had 75s, but one of those students got a C and the other student got a B for that same 75. That's not right. That's not a function. So one input goes to only one y. That's a function. So this is actually a function here. It works right. But what about this one over here? Let's say this circle contains the x's, this circle contains the y's. It will be not a function because as you see in red, this 7 is going to 2 different y's. So not a function. Let's move on to other things you need to know about functions. If your relation is a function, y is the same as f of x. And we kind of mentioned that at the beginning of the second page. Here, y is the same as f of x. Alright, and to evaluate a function is to, so this is a new concept, is to substitute its input variable with a given number or expression. For example, evaluate the following function: f of x equals 3x minus 4 for x equals 5. All we're doing is replacing the x's in this function with 5. So again, this is stated as f of 5. So you say this as f of 5. F of 5 equals 3 times 5 minus 4. 3 times 5 is 15. So, and 15 minus 4 is 11. So, f of 5 equals 11. F of 5 equals 11. Simple as that. All we did was make a substitution. For every x in that equation, we substituted it with 5. So our input was 5. That's what we plugged in. And our output is 11. So if I ask you to write this as a point, this information as a point, then your input is always your x, right? You plugged in a 5 for the x, and what did you get out for your y? You got out 11. All right, your output is what is a result of you plugging in your x value. So you could plot that as 5, 11, for example. Let's try that same function f of x when x equals -3. So I want you to do is use this same function and evaluate that function at x equals -3. So all you have to do is replace the x with a -3. So 3 times -3 minus 4, that's -9 minus 4, which equals -13. So how could you write that point? Well, that point would be, what did you plug in for x? -3, and what came out for y? -13. So these are actually, if I say graph the function, you could use these points, for example, if I ask you to graph the function. But if I say evaluate this function, all you have to do is write, for the first one, f of 5 equals 11. And for this one, f of -3 equals -13. Moving on. What about x equals 0? Using the same function. We have f of 0 equals 3 times 0 minus 4. So f of 0 equals 0 minus 4. F of 0 equals -4. What about x equals w? F of w equals 3 times w minus 4. Those are not like terms. That's all we can do for that. So that is your final answer. What about f of 2w? That means 3 times 2w minus 4. You can actually multiply 3 times 2w. So f of 2w here equals 6w minus 4. And what about when x equals w plus 1? So instead of writing the x again, we're going to replace all of it with w plus 1. So that means 3 is going to be multiplied by w plus 1. And in this case, we're going to have to distribute. So f of w plus 1 equals 3w plus 3 minus 4, which equals to 3w minus 1. Let's move on. Let's try a new function to evaluate. F of t equals -3t squared plus t minus 1. So I'm going to try the first one out, and I want you to try the other two, okay? So starting with f of 0, let's plug in a 0 for t. So we're replacing all of the t's with 0 now, plus another 0 minus 1. So that's going to end up being 0 plus 0 minus 1, which is -1. So f of 0 here equals -1. So what I want you to do is pause the video and try f of -1. So if you ended up getting -5 as your answer, then you are absolutely correct, because when you make the substitution first, and this is where most people mess up, they do not square the -1 first. So according to order operations, you have to square -1 to get +1. Then multiply that -1 times the -3 to get -3. And then -3 minus 1 is -4. -4 minus 1 is -5. Now go ahead and try the next one. Pause the video and try it. So if you end up getting f of -2 equals -15, then you are absolutely correct. Let's move on to the next function. we have g of t equals negative absolute value of t plus 2, then plus 3. So those vertical lines are absolute value signs. And absolute value is just the distance between that number and 0 on the number line. So absolute value will always be positive because it means distance. Alright, so let's get started. We're going to substitute our t for a 0. So we have 0 plus 2 in absolute value signs plus 3. Then we have a negative. 0 plus 2 is 2. So I still have the absolute value there. But what is the absolute value of 2? The absolute value of 2 is positive 2. It's already positive 2 there. But it connects with the negative 1, the negative on the outside. So you have that, still have that negative on the outside. But the absolute value of 2 is 2. So you just bring that down. It's just not in the absolute value vertical bars anymore. Plus 3. So that negative is coming from the outside, not from the inside, okay? So negative 2 plus 3 is 1. So g of 0 equals 1 here. Let's try g of negative 5. We have negative absolute value of negative 5 plus 2. Close absolute value plus 3. So that is negative absolute value of negative 5 plus 2 on the inside. So we're working our way on the inside. That's negative 3 on the inside of the absolute value sign. But we put down our negative from the outside. But what is the absolute value of negative 3? So what is the distance between negative 3 and 0 on the number line? Is 3, right? So you bring the 3 down because the absolute value of negative 3 is 3. But that negative is on the outside of the absolute value, so it has nothing to do with the absolute value symbol. Plus 3, so that'll be 0. So g of negative 5 equals 0. Let's try g of 7. That's negative absolute value of 7 plus 2, close absolute value plus 3. So that's negative absolute value of 9 plus 3. Again, negatives on the outside. You just rewrite that. The absolute value of 9 is 9 plus 3. So negative 9 plus 3 is negative 6. So g of 7 equals negative 6. Let's move on to this function. We have a rational function here. So we plug in 0. 0 minus 1 over 0 plus 3. So h of 0 is simply negative 1/3. You try h of negative 1. Pause the video and try h of negative 1. If you ended up getting negative 1, you're right, because you have negative 1 minus 1, which is negative 2. And then you have negative 1 plus 3, which is positive 2. And if you divide negative 2 by 2, you get negative 1. If you try h of negative 3, however, here's what's going to happen. You have negative 3 minus 1 over negative 3 plus 3. So h of negative 3, notice, will be negative 4 over 0, which we say is undefined. So whenever you have a 0 under the line, it's undefined. So here we have an issue. In math, we do not like zeros in the denominator. So if our denominator equals 0, we call that undefined. Now, what x value did we plug in to make it undefined? Negative 3 in this case. We plugged in a negative 3 and we got undefined. So this x value is excluded from our domain of this function. So that's the only value that will be excluded, because notice we have x plus 3. If we set that to 0, notice that what we get is x equals -3. So -3 is the only number for this function that is excluded from the domain. So therefore the domain of this function is all real numbers except x equals -3. And the way you write that in set builder notation is the braces x, this vertical line here, which means such that in math, it means such that x cannot equal -3. And if we wanted to write an interval notation, we'll put a parenthesis, -infinity to -3, parenthesis, union, parenthesis, -3 to positive infinity. So there are 3 different ways you can write the domain of this function. I want you to be familiar with all 3. Be able to write at least one of them out, but just be familiar with all of these actually mean the same thing. They're just written in different formats. The easiest way to determine the domain of a function is to first find out what x cannot be. In other words, the restrictions. And there are only 2 restrictions you have to be concerned about in math, and that is when an x causes the denominator to be 0, and again we call this situation undefined. And we also don't necessarily like when there are negative numbers under the even root radicals. So we have to determine what x values will make that happen. Let's graph a function. The graph of a function is the graph of all of the ordered pairs of the function. Here again we have an example of a linear, and before we were dealing with a linear equation, we called it, but now since this is a function, we can actually call it a linear function. And again, I notice linear because the x is to the first power, and f of x is the same thing as y in this case. So since it's linear, you can put -1, 0, 1. You can put more points than that if you want, but since it's linear, 3 points are good. So we have -1, plug that in, f of -1. So notice that we're evaluating this function. Same thing as substituting x values into your function. So 3 times -1 minus 4. What do you get as your output or your y? So y again is the same thing as f of x. So when you plug this in, what do you get? 3 times -1 is -3. And -3 minus 4 is -7. So your point is -1, -7. Next, if you plug in a 0, what do you get? F of 0 equals 3 times 0 minus 4, -4. So your point is 0, -4. And then you have a +1. So you have 3 minus 4, which is -1. So your point is 1, -1. Now when you plot that, you go left for -1, down 1, 2, 3, 4, 5, 6, 7, for -1, -7, 0, -4, 1, 2, 3, 4, and 1, -1. And it's best to use a straight edge for this, meaning you should have something that has a straight edge on it and then draw your lines. I'm winging it right now, but I do not like crooked lines, okay? So use a straight edge to help you draw straight lines. Now, what is your domain of this function? Well, notice that I put arrows on the end of this line because this line continues forever. What x values does this line cover? It covers all of them. Notice it's continuously going this way and it's continuously going this. So it's covering this whole entire x-axis. And because it's covering this entire x-axis, our domain is negative infinity to positive infinity. Our range is the same because our line is going continuously this direction on our y-axis, and it's going continuously up. So on the y-axis, it's covering the entire y-axis. It's covering all the y's below here and all the y's above this. So domain and range is pretty easy for this linear function. Let's move on to this function, which is not linear anymore. Can you tell me why? Well, notice we have degree 2 here. So when the degree is 2, we call it quadratic function. Alright, so you need more than 3 points in a situation like this because you want to know, you want to have an accurate interpretation of what the graph looks like. I know that quadratic functions have a U shape. It's going to be a parabola, as they call it. So we can try -3, -2, -1, 0, 1, 2, 3. Now I'm going to help you with -3, and what I want you to do is pause the video and try the others. So we're going to plug in -3 here. That's -3 squared plus 2 times -3 minus 3. Now -3 here is +9, right? And then we have a -6 minus 3 because 2 times -3 is -6. So 9 minus 6 is 3, and 3 minus 3 is 0. So this point is actually -3, 0. Now what I want you to do is pause the video and determine the rest of the points for -2, -1, 0, 1, 2, and 3. So go ahead and check your points with these points. And now what we're going to do is plot the points. So we have -3, 0. We have -2, -3. And for the sake of time, I'm not going to label the points, but it's a good idea to label your points. -2, -3. -1, -4. 0, -3. 1, 0. 2, 5. And this is a pretty good indication of how this U looks. So I'm going to stop there. As you can see, it looks like so. Kind of missed that one. So make sure it looks like a U for quadratic equations. Now, the domain of this function, notice how this continues. It inches its way to the left, so it covers the left side of the x-axis, and it also it's going to inch its way to the right slowly but surely, so it covers all of the x-axis. So the domain of this quadratic function here is -infinity to +infinity. The range is different, however. The range is the bottommost point to the top. So you can think of it as what's the floor of this shape and what's the ceiling of this shape. And you start from least to greatest. So we're going to go with what's the floor of this shape. Now the bottom point looks to be around here. 1, 2, 3, 4. So that's -4 is actually touching -4. And what is the ceiling of the shape? It's going continuously up on the y-axis, so it's going on and on forever to positive infinity. Let's move on to the next graph. it is an absolute value graph, it will be a V shape. V shape, whereas the quadratic one is a quadratic, whereas the quadratic function is a U shape. So I'm going to start with the first point, -3, but what I want you to do is fill in all the rest of the points. So if we plug in a -3 here, we have absolute value of -3 plus 2, close absolute value plus 3. Notice here, inside we have a -1. However, inside of that be the absolute value of -1, which is 1, plus 3. So you will actually have 2. So your point is -3, 2 for this one. So I want you to pause the video and try out the other points. Alright, so go ahead and check your points now. What I'm going to do is proceed by plotting the points. We have -3, 2, 1, 2, 3, 2, -2, 3. We have -1, 2, 0, 1, 1, 0. And as you can see, the right leg of the V is forming here. So I'm going to stop here. 2, -1 is good. But as you can see, it's doing something like this. It's an upside down V. The domain, again, it covers the entire x-axis. Again, these arrows mean this continues. If it keeps going, notice it'll cover the entire x-axis. So that's -infinity to +infinity. And the range, the floor, notice is continuously going down. So that's -infinity on the y-axis, right? But the top part, the ceiling of this shape is this. And what is the corresponding y for that? It looks like it's 3. Alright, so we're going to put 3 here, and it actually touches that 3, that point. So the ceiling of that point is 3. Alright, let's move on. Visual way to determine if the graph is a function is the vertical line test. So the vertical line test tells us a lot. Basically, if we draw a vertical line through our shape and we are able to hit the graph more than once, it's not a function. So for example, if I draw a line through this shape, notice that I hit this shape more than once. Once here, then twice here. So it is not a function. What is the domain? The left, notice that this circle doesn't continue. The left x value is -1. And the right value, x value, is 5. So the domain is from -1 to 5. The range is from -3 to +3. Moving on, this is a function because you only hit this graph once. If you draw any vertical line, domain, if it's going off the page like this, that means it should have arrows. It's continuing, -infinity to +infinity. Range also going down, and that's going up, so -infinity to +infinity. Moving on, this one is tricky. Notice if I draw a line right here, bam, I hit it once, bam, I hit it twice. Not a function. And notice on this one, I can draw a vertical line anywhere, and it is a function. Group challenge. In class, I give this challenge as a group. What about the following examples? Y squared equals x plus 7. Is it a function or not? Again, this is also asking the question, is is, you may also hear it like this. Determine whether a given equation defines y to be a function of x, which really is sort of just asking, is it a function or not? So does the given equation define y to be a function of x? So what you could do, you could graph this, how we've been graphing our other equations, or you can use Desmos for a shortcut, right? So I can go to Desmos, desmos.com, and I can simply put in the equation to see the graph of it. If it passes the vertical line test, then it's a function, right? So we can put the equation in, which is y squared equals x plus 7. And notice it's a U shape, but it is sideways. So notice that it does not pass the vertical line test. And that could be your vertical line. You can see right here that it doesn't pass the vertical line test, because it hits right here and it hits right here, right? And like, this is good to point out. See, that's 2.646, and that one is negative 2.646. So notice that that 1x value is going to two different y values. One is positive, one is negative, same number, but one is negative, one is positive, so they're actually two distinct numbers. And so it does not pass the vertical line test. And if you look at the domain, it would be, so this is -5, -6, -7. -7 to positive infinity, and the range would be from negative infinity to positive infinity, because this continues going down, this side is continuously going up. So let me write that. Is it a function? No, it does not pass that vertical line test, and it looks like -7. That should be a bracket to positive infinity, and range from negative infinity to positive infinity. You can also put x squared plus y equals 3 into Desmos. Right, x squared plus y equals 3. Notice here we have a U shape again. It does pass the vertical line test. You can look at the but notice that, spread this out a little bit. The domain is from negative infinity to positive infinity, but notice the range is negative infinity to what this is right here, and that's 3 on the y-axis. So it is a function. It passes the vertical line test, and domain is from negative infinity to positive infinity, but the range is from negative infinity to 3. And that concludes this video on functions.